In today's class, let us understand about nuclear plant and its layout. As you can see in the diagram, a nuclear plant consists of a nuclear reactor, heat exchanger, steam turbine, alternator, condensator, etc. These are the important components of the nuclear power plant. So, how it works, let us understand one by one the working and important components. Here the reactor and the cooling circuit have to be heavily shielded so that if any radiation hazards has to be eliminated completely, because the tremendous amount of the heat energy which is produced in breaking of the atoms, that is uranium or other similar metals of the large atomic weights into metals of lower atomic weights by fission process. So all this process is carried out in an atomic reactor, and after the reaction it is extracted by pumping fluid or molten metal like liquid sodium or gases through the pipes. Now the heated metal or gas is allowed to exchange its heat with the circulation elements. So heat exchangers have been used for the circulation. So in the heat exchanger generally the gas is heated or steam is generated. Further, it is utilized to drive a gas turbine or steam turbine coupled to an alternator. This was the general principle of your combustion engines, thereby generating the electrical energy. Now when we look at the different components of the nuclear power plant, nuclear reactor is the one of the important component. So what is the role of a reactor? So reactor is that part of the nuclear power plant where energy is released as a result of nuclear fission process. The radioactive material is utilized to heat the coolant, which may in turn generate steam or the required amount of energy which can be further used for the gas turbine. So the basic components which a nuclear reactor consists of are fuel, reactor core, moderator and shielding, control rods and reflector, coolant and reactor vessel. Now when it comes to fuels generally what we use in the reactor are uranium-235-92, plutonium-239-94 and uranium-233-92. Among these, uranium-235-92 is the naturally available up to 0.7% in the uranium core, and the remaining uranium-238-92 and the other two fuels like plutonium-239-94 and uranium-232-92 are formed in the nuclear reactors during the process of fission. So from uranium-238-92 and thorium-232-90, they are formed due to the absorption of neutrons without fission. So these are the different types of fuels which are used in the nuclear reactor. Next important component is reactor core. What is this core? It contains number of fuel rods. You can observe here fuel rods are available in the nuclear core and they are made up of fissile materials. Generally they may be diluted with non-fissionable material also for obtaining good control of the reactor or to reduce the damage from the fission, because fission process occurs very rapidly, so any damage that might occur has to be reduced. So here once the uranium gets oxidized rapidly, the fuel rod should be clad with aluminum, stainless or zinc. Next important component is moderator. The role of the moderator is to control or to moderate the reactor core and reduce the neutron speeds to value that increases to probability of fission occurring. So here the control process has to be taken care of with the help of a moderator. So for that purpose we use graphite, heavy water or beryllium can be used as the moderators for the natural uranium control process. Next is shielding. Shielding plays very important role in your nuclear reactor, as the purpose of shielding is to give protection from the deadly alpha, beta particle radiations and gamma rays as well as, so that the shielding has to be provided in such a way that there is no leakage happening. Next is control rods. So in the control rods, as the name indicates, it plays a very important role in controlled reaction which has to be started in the reactor from the cold process. Initially the reactor is in the cold, that is the temperature is very less, and the chain reaction has to be maintained at a steady value during the operation of the heating. So in order to do that, control rods plays a important role by releasing in a controlled way the fuel is released into the nuclear core reactor. It's not released together. Next is a reflector. The role of reflector is, this reflector completely surrounds the reactor core with the thermal shielding arrangement, and hence to bounce any escaping neutrons back into the core. Generally, it is very much necessary to provide some methods of cooling to the reflector, as it gets heated up whenever it collides with the neutrons and the atoms. And the last is coolant. So as the name itself indicates, a coolant transfers heat which is produced inside the reactor to the heat exchanger. Whenever the water is used as a coolant, it takes up heat and gets converted into steam in the reactor core. Similarly, which is directly used in the turbine also. So coolants commonly used as gas, water, heavy water, liquid metals, and some organic liquids also be used as the coolants. Next is reactor vessels. These reactor vessels, these enclose the complete reactor core and reflects and shields. So this is the strong walled container generally that also provides the entrance and exit passages for the directing of the flow of coolant. So this is how the different components of your nuclear reactor core works in a generation of electricity. Thank you.